going to follow the same kind of a pattern as the previous panels. We'll start with a couple of lightning presentations from the UT Austin community. And so first, I'd like to introduce you to my colleague on the Good Systems executive team, Dr. Ken Fleischmann, who co-leads the project Making Smart Tools Work for Everyone. And everyone, again, I think is the word over there. Dr. Fleischmann is a professor in the School of Information at UT Austin. He is the founding chair of Good Systems and the founding director of the undergrad studies for the School of Information's BA/BS in Informatics. He is also the founding editor of the ACM Journal on Responsible Computing, something that he launched very recently, maybe 2 years back.
Just this past year, Chandra.
Just this past year, yeah. His research and teaching focus on the ethics of AI and more broadly on the role of human values in the design and use of information technology. So why don't you go ahead and start us off, Ken?
Thank you so much for the kind introduction, Chandra. Awesome. Thanks, everyone, for being here. So I'm going to talk about the Smart Hand Tools project within Good Systems. It's one of the 6 core research projects in Good Systems. So my co-leads on the project are Sherry Greenberg from the LBJ School of Public Affairs, Raul Longoria from the Department of Mechanical Engineering, and Sandeep Chinchali from the Department of Electrical and Computer Engineering. So our goal is not to replace human workers, but actually to put AI in the hands of workers. So we're talking here about middle skill workers, workers who typically have an associate's degree or equivalent training and are doing important work, whether that is in welding or in many other occupations that are increasingly, of course, at threat of automation. And so we think that smart hand tools, by using embedded sensing, Internet of Things, and edge intelligence, can promote worker safety and well-being, expand the middle skill workforce, and ensure that we'll be able to build up the robust manufacturing base that this country desperately needs. So these are the research questions that drive our project. They're based on the Good Systems Define, Evaluate, Build framework. So we've done a series of case studies in terms of the social science side. We've also have a series of prototypes on the technical side. So we have our first case study was with Longhorn Racing, which is a student group here at UT that builds and races combustion, electric, and solar-powered vehicles. And the 14 interviews we did with students in this project helped cue us into welding as a really important, dangerous application that was very much of interest. As Chandra mentioned, we really do want to make sure that we're building work for everyone and tools that work for everyone. So we focused on a particular population of deaf welders. So people who identify as deaf and are welders by occupation. And so we identified a Facebook group and were able to interview some of the members of this Facebook group to better understand their unique experiences with welding and how, for example, taking auditory information and converting it into visual information could serve this population and make it easier and safer for them to do their jobs. We're now collaborating with the Austin Community College and we're working with the Department of Welding on first interviewing instructors, and now we're just about to start interviewing students about their experiences with welding education. They actually have a $70,000 welding simulator that's sitting in a closet, sort of collecting dust, not really being used. We want to make sure we can do something that's actually going to be used, and that starts with the that important aspect of trust, of course, as we talked about. And then also we're collaborating with the City of Austin. This is part of the interlocal agreement between UT Austin and City of Austin. And so we're collaborating with 5 different city departments. You can see it's quite a range of departments there. And so we're doing interviews both with managers and with workers who are using hand tools. Our first prototype was a smart rotary hand tool. So it's a very simple, fairly safe device. So we just attached a Arduino Nano with IMU sensing, current sensing, a microphone. We built a rig for physical measurement to be able to detect the forces that are involved in different motions. We also did a lot of user testing with the prototype first. We're actually now over at Texas Robotics in Anna's gym, we're doing some synthetic data collection using a robot. So we're actually having the robot use the tool configured along ways, mimicking the ways that humans would use the tools. We also have an augmented reality welding trainer that we're building where we're actually just using a cell phone. So this is something that workers bring to them on the job and that every welding student has on their possession and can very easily, we actually have like a little $10 frame, you put your smartphone into it, and it basically turns it into a cheap AR setup. And so in this way, in addition to, of course, the primary data collection for this is with human users of these AI-based tools, but we also want to be able to augment that by automating the tool use and being able to use that data, and also having real humans using fake tools like this to be able to explore the range of the applications of smart hand tools. So thanks to MITRE in particular, and Microsoft and Good Systems for funding this research. Thanks.
Well, thank you, Ken. And now we'll move to Joydeep Biswas. He will be giving a talk on living and working with robots. Dr. Biswas is an assistant professor of computer science in the UT Austin College of Natural Sciences. His research areas include perception, planning, and failure recovery of autonomous mobile robots. These topics support his goal of having autonomous service mobile robots deployed on a campus-to-city scale, both indoors and outdoors, performing assistive tasks accurately and robustly on demand. Wow, that's a whole lot of things that you obviously are doing. So go ahead, Joydeep.
Thank you. So I'm representing a large team, which is called Living and Working with Robots. And to put it in a nutshell, we build and study robot systems designed to benefit the communities in which they are deployed. This is a very large team, and all of the PIs are actually listed on the slide, including Sam Baker, Peter Stone, Justin Hart, Elliot Hauser, me, Aaron Shoait, Junfeng Jiao, Katie Pierce-Meyer, Louis Senti, Samantha Shuri, Kerry Stephens, and Maria Steva. I wanted to give a big shout out to the wonderful team and wonderful collaborations that we've had as part of this. So in particular, what are we actually looking, when we get down to it, what are we actually trying to do? So we're trying to deploy robots on a campus scale, right? We want to understand the impacts on the campus communities over the long term, right? We want to build methods and data sets for community-aware autonomy, community-robot interaction, and community factors research, right? And we want to enable repurposing of these robots as a step towards general purpose autonomous service robots, such that anybody in the community can ask any of these robots for arbitrary tasks. Like, that's the dream goal. Of course, we're nowhere near there. There's a lot of things that need to happen to actually get there. So I'm going to actually provide a vignette of some of the recent results of the team members and what we've been doing in trying to address parts of the problem, right? So one problem that we have is that how should robots navigate amongst humans? Now, this is something which we actually take for granted, but in this scenario, as you see, there's a robot and there's a human, then they're in a narrow hallway. What happens is that if we trust our robots to just signal their intent only using turn signals, like with an LED, it turns out that humans are actually not very good at interpreting as to what the robots will do. So you can see there was an awkward interaction over there where the robot just came right up to the human. As opposed to that, I mean, Justin Hart's been looking into what if we have these robots have gaze and then communicate what they're trying to do, and then the human is very clearly able to understand what the robot's trying to do, is able to they're both able to like sidestep each other, right? So these are an example of the kinds of things that we want our robots to be capable of doing in the real world. And what better way of our robots, teaching our robots how to interact in like crowded scenarios than to tell them and to teach them via a data set of how to behave in these settings. So we actually had this very large project. The lead PhD student is Haresh Karnan, and with a very large number of collaborators. We collected this data set of how these robots should actually negotiate these complicated settings, including with UT Austin's football games, right? And we hope that this data set will actually be helpful in leveraging and teaching robots how to navigate in these challenging scenarios in the future, right? So so this is some work from Luis Sentis's group on how you have robots which are able to sense very precisely interactions with and around humans, including, for example, soft contact navigation in like very crowded settings, and actually work with this, right? So he has some really cool work with this Bumpy Bot, which is a contact-aware robot, and humans can actually sit on them while driving around and so on. So multi-agent interaction is not just between humans and robots, but it also includes robots and robots. If you have multiple robots in an environment, it doesn't help if they clog up the roads and so on. So in this work led by Jin Su, who is a PhD student, they worked on the scenario where the robots communicate to each other what they're trying to do, and like each robot hallucinates some obstacles such that they're both actually able to get past each other in a very natural manner in these crowded settings. Okay. All right, so how do we learn to do cross-disciplinary community-oriented research? So this is actually a big focus of a recent grant that we got on growing convergence research. The lead PI on this was Luis Sentis and Kerry Stephens and gang. We're all very excited about this. So one interesting thing about this project is that we're trying to understand, as we build these systems, how do we perform science of science? How does the science get developed? How like team dynamics evolves? When you're deploying these systems in the world, what are the interactions between the deployers and like the developers, right? And this involves, of course, a large amount of data collection, and Maria Esteva from TAC in particular has been instrumental in codifying how we can actually reason about the processes that generate the data, how to curate them, how to actually annotate them such that they persist over time, right? And finally, some more recent work that we've been looking at in my group is how can we have robots reason about human environments over long time scales, right? And one key insight that we have is that we want to take into account semantics of the world. We want to take into account objects that happen to be in the human environments, and this gives us a more flexible way of reasoning about them. And we've seen, for example, using this high-level understanding of the world leads to more accurate estimation of the robot in the world. Another example of reasoning about semantics is that if you want to teach your robot to stick to, for example, the trails and not drive over the grass, including in scenarios where the sidewalks are not so clearly marked as in this trail, how can you teach them to do so? And this is an example deployment where we showed that we can indeed, with a very small amount of demonstrations, teach our robots to decide where they should navigate over and when they should not. Okay. So there's a very quick whirlwind overview of all of the many things that we're looking at, but hopefully this will help open up the discussion about how we can live and work with robots in the future. Thank you.
Thank you, Joydeep. And yes, so now we move to welcoming one of our very own, Josh Harguess. He works with MITRE. And for those of you who don't know, he received his PhD from UT Austin in 2011. Dr. Harguess is the Department Manager of AI Security and Perception in the AI and Autonomy Innovation Center at MITRE Labs. He joined MITRE in 2020 to continue performing research and advising sponsors, partners, and staff in applications of computer vision and machine learning to real-world problems. Before MITRE, he spent a year at Shield AI, performing applied research on computer vision, and 7 years at Naval Information Warfare Center, Pacific, applying computer vision and machine learning research to Navy and related problems. So, Josh, we are very pleased to have you back. Thanks for traveling all the way from San Diego to be with us this morning. So, Josh, why don't you start off with some of your general thoughts. What does a trustworthy human-AI partnership look like? Both Ken and Joydeep talked about that in different ways. Joydeep more in the context of on the field, in the field applications, and Ken more in the context of long-term. This whole notion sometimes that people might feel, hey, by giving away my knowledge to AIs, am I investing in my future unemployment? Kind of a thought process. So can you address some of those issues?
Yeah. So first, thank you very much for the invitation. It's been a really amazing symposium. So Very excited to be here. So I'll speak a little bit to some of the customers that are very much overlapping a lot of what we've been talking about here. So some of the sponsors we deal with are Department of Defense, national security folks, and we have no intention of replacing them. We want to work alongside them. We want to give them tools to do their jobs better. So it's very much like the Smart Hand Tool kind of project, and very much like working and living with robots. So I think that's a really important differentiator. A lot of AI is built to intentionally replace people, just like technology tools in the past. But that's not our goal. That's not our focus. We have, when you speak with the Navy, when you speak with these folks, they have people coming in that are enlisted. They have no intention of not bringing them in. So I guess that's kind of the fundamental piece there, is that we want this technology to be used by them, and we want them to be able to enhance their jobs using this technology. And so a lot of what we've been thinking about at MITRE is this consequential use of AI. So it's got several different terms, but it all kind of means the same thing. So we're not talking about shopping online. We're not talking about selecting a pet, something like that. These are situations like surgery, like military applications, where people's lives are potentially on the line. So thinking about assurance, defining assurance, the different pieces that are involved in insurance, the NIST AI risk management framework, I think that's a really good framework that we should be kind of using going forward. And there's some elements in there. Trust is definitely one of them. Security, so I do a lot of work in AI security. That's a big piece. So if you do have a system and you want to understand the vulnerabilities of that system and how to defend that system against potential attacks or nefarious uses, how do you go about doing that? How do you build a red team that can actually kind of attack that system and assess those vulnerabilities? That's a piece that we've been working on with folks like the Chief Digital AI Office, who was originally called the JAKE, Joint AI Center. So that kind of work is really what we're kind of focusing on in my department. But obviously there's lots of work to be done in bias, and I said already, trustworthiness, resilience, robustness. I'm also working with CDAO on a program called JADIC, and this is about doing T&E, just basic T&E for AI. There's just a lot of ground that we need to sort of make up in this space that has been addressed in other fields of technology that really hasn't happened here yet.
Ken, picking off what Josh just mentioned, and some of the discussions we have already had, the idea that we should not be looking at solutions, but first understand what are we trying to understand and resolve in the first place. From that standpoint, what are your thoughts on this whole area of trustworthy human AI partnerships? What are some specific things that we can do to alleviate anxiety and concerns that might originate from humans?
Yeah, thank you, Chandra. So I think along the lines that Josh was laying out, that it's really important that, I think the most important thing is not that humans trust AI, but that humans have the ability to build informed trust judgments about AI. So just trusting every single AI, won't get you very far. That can be very, especially in terms of the adversarial angle, that cybersecurity issues that Josh alluded to. So enabling, empowering humans to make informed trust judgments about which AI to trust when, under what conditions, is really critical. Of course, a person is not going to use an AI if they don't trust the output of that AI. And one of the ways to understand, to be able to trust that AI and build that informed trust judgment is to understand how the AI is working. I actually think of course, there's been a big buzz about ChatGPT and large language models and generative AI overall. And I actually think this has been a good thing in terms of raising awareness of, first of all, the ubiquity of AI, the role that it's playing in our work, in our lives, the fact that if you have a cell phone that you're using for directions, you're using AI for all kinds of things that we do in our everyday lives, we're constantly using AI. But we may not be consciously thinking about that. So it sort of forces us to think about it. It also, directly allows us to interact with the interface to actually generate the response ourselves, to see what the AI produces and be able to sort of question and interrogate that. So I think that actually that also kind of puts that AI directly in our hands, allowing us to form our own informed trust judgments about how soon our particular jobs, be they knowledge work or middle skill or what have you, would be replaced by AI. And I think most people, once they see that certainly there's a lot that AI can do, but still there's a lot that humans can do that AI can't yet do and may never be able to do, at least not quite the way that humans do. So ultimately that trusted relationship between human and AI has to be humans getting to do what humans are best at and leveraging AI for what AI can be best at.
That notion of what each entity can do best, I think it's interesting. So Joydeep, in your work, you were showing two robots. What I understand from some universities that have deployed robots within their campuses is that robots sometimes are very kind or too kind. Perhaps they're programmed to be too kind. So, when they see any kind of a pedestrian, they are respectful, they are very nice. What is the general thinking as robots are built to interact with humans?
So this is a great question, and I think this comes down to what is the appropriate action to do at what appropriate time, and what cues should you pick up on to make these decisions. And I think the answer is complicated because there are far too many factors that you can pre-enumerate. And part of the technical challenge here is that how can we build robots capable of picking up new cues? An example of that is social navigation, which is, I think, what you're alluding to. And humans are, on the surface, seemingly very good at it, but also humans make mistakes as well. But the interesting thing about when humans make mistakes, they very quickly catch on, oh, wait a second, I think that person was trying to go left, and I misconstrued that they were going to go right, and they quickly resolve themselves. I think we need to have robots which are not only good at picking up the cues, but also very quickly able to correct their mistakes when they move ahead. So in the social navigation context, we've also thought a lot about, is it sufficient to just look at humans? And it turns out that there are a lot of settings where social navigation isn't just about looking at humans. And I showed some videos that we collected of deploying these robots in these football games, and you have the line of people who are trying to interact with a food truck. So suddenly, social navigation is not just about not perturbing humans. It's also not cutting into the line for the people who are waiting to buy tacos at the taco truck. So what are the cues that you should pay attention to? Should you expand social navigation to keep track of taco truck? What other trucks can you think of, right? This is an unending and open list of things that you need robots to reason about. And it's an open question as to how we will have robots pay attention to all the cues. But this is really front and center about how we're thinking about robots which can reason about what cues to pay attention to, understand when they made a mistake, and correct and improve upon that fluidly over time. And I think that's a challenge.
So, what if you talk something to the effect of being cued in, designing for appropriate responses, et cetera, and that brings up the whole notion of competence-aware systems. So, Josh, from your standpoint, could you elaborate on how competence-aware systems might be relevant for deploying autonomous, semi-autonomous systems in the real world? Any examples that you can provide that MITRE is working on right now?
So one that speaks a lot to what Joydeep just mentioned is that human-machine teaming aspect. So we do have projects going on, for example, with the Army, where there's an autonomous vehicle or a semi-autonomous vehicle that's part of the actual deployment. So they want to be able to have some sort of an operation. They have humans on the team. Obviously, they're not going to leave them behind. And they want to bring this new autonomous vehicle, which could be a large vehicle, could be like a Jeep or a Hummer or something like that. It could also be drones that are flying in the sky. It could be communication with a very high elevation asset. But they want them to be part of the team. So there has to be this sort of natural way of communicating between the humans and the machines We're definitely not there yet, but I definitely agree with the sentiment. Like we need systems. We need ways of communication that are easier, a little bit more natural to cue between the human and machine for this human-machine teaming.
So, going away from the abstract, which is this whole notion that humans and AI, they can interact in very beneficial ways in the future. What steps can you think about that we can implement now to, and not in a very abstract way? Yeah, we have to look at competence. Each of the entities does things that they are competent on. Not in the abstract, but now, what can you say should be our pathway to ensuring a nice, easy transition? Because it is the livelihood of people that we are talking about. What concrete steps can we start taking now?
I can take a stab at that. So I think one key insight, I think, which we're trying to draw on is that it's important to involve the stakeholders throughout the process rather than at the end. As technologists, we tend to get a little bit sidetracked in like, what's cool about the technology, and let's just keep developing it on its own, like someone will find a way of use for it. But sometimes it's better to think a little bit about what are the problems we're actually trying to solve, right? So in the context of the living and working with robots, we reached out to several organizations on campus, and like the UT Libraries is one organization which were expressed interest in, for example, utilizing these robots for transferring books between libraries. And that gave us a context of like, what are the key technical problems that we need to solve? Not in a vacuum, not just for the sake of solving the technology, but for solving that thing which humans really have a need for. So I think alignment with what are the needs of the human is important, but now when you have like a concrete goal, we want to be able to traverse between libraries. Now you can think about, okay, so if the robot's going down Speedway, can it misunderstand like where the red brake transitions onto the grass? Can it misunderstand like where is the walkway? And now the questions of competence comes into play of like, well, given the task and given the scenarios that you're going to be deployed in, can you reason about the competence? So I think maybe that gives some insights on ways in which we might do this in the future, which is start thinking about what are the problems you're trying to solve and talk to the stakeholders to understand what are the things that we should address rather than do it in isolation.
Josh, any further insights on that?
Yeah, so one thing to think about is how do we actually build products today? One of the problems with working with government entities is that they have very old-fashioned ways of doing business and of doing projects and products, which are built around waterfall that could take 3 to 10 to 20 years. So one way we actually are trying to make change there is using Agile and Scrum methodologies to get user feedback quickly, to get stakeholder feedback quickly, engage the users, bring them into the design and development process early, and keep them engaged throughout the product cycle. So that's something that we've been working very hard on within MITRE and with our sponsors, and it really has been effective in making change in that direction.
So we've been really delighted to partner with City of Austin. So we started with, I put the social science team slides first. Part of it is the social scientist up here, but also part of it is because we really wanted to start with the users. So everything that we're doing is driven by the workers that we're focusing on and trying to help and figuring out what is it they could actually use in their jobs, in their lives, that actually be beneficial to them, letting that drive the design. So Raul and his team have been really great about taking the input from the social science team and employing it directly in the design of the technology.
Yeah, so, this all brings back the issue to AI, robots. They are not simply technology. It is firmly entrenched in the notion of human-AI, human-machine interactions. Can you give some specific examples, and this open to all of you, of where the two of them are actually helping each other out in a beneficial way? Can you give concrete examples of that right now?
Sure. So one example is that we have a wonderful set of staff, including Corey and Keith, who help maintain the robots, which we do research in Anna's gym. And as part of maintaining the robots, is we have to take delivery of parts, and for whatever reason, they come to the computer science building, which is a different building on campus. And it's a chore to get these packages over. So one of the things that we've tried to, that we played around with is using these robots to carry the packages over from GDC to Anna's gym as an example of a useful task. Now the question is, now the second question was that how can humans, since we're talking about this in a symbiotic manner, robots assisting humans, and I gave an example of that, how have humans assisted robots? So in the past, we've actually explored things like robots without arms having to take elevators, and there they can't press the button because they don't have arms. But they could ask a bystander, and it's actually not hard for a bystander to press a button on an elevator. So, or hold the door open for the robot. So if humans have robots in the environment where they are performing useful tasks for everyday humans, we hope or we believe that the humans would also, in fact, be willing to take small steps to assist the robots to make them more capable in assisting the other humans in the environment. So that's just some two concrete anecdotal examples.
Josh?
Yeah, I can go over. There's a few concrete examples. Some of them I a little bit sensitive, but I can talk about one that's pretty simple. It's like base security. So you have some entry points into some sort of a base. Maybe it's an army base, and you want to keep track of folks that are coming in and out, and if they have the appropriate clearances and things like that to be on base. So previously, this would take a lot of analysts looking at security cameras, or even previous to that, doing just hand and eye, actual verification of these folks. But there are real deployments now of computer vision systems that are helping us do that job. And so we've reduced, a number of analysts, 20 analysts with video screens in front of them, to one that just verifies the results that are coming back from the computer vision system. And so that one has helped tremendously. Obviously, it's not 100% accurate. There are issues. There's ways to fool the system if you're nefarious, things like that. But these things are known. So the humans know that there are issues with the system, and these are the issues that you might see. But it's helping tremendously reduce the number of man hours, and maybe somebody that's tired after a very long shift, they're missing some things that are on the screen. So it's backing up basically the human capability in this case.
It's interesting talking about the assistive nature of robots. One of the things that my wife loves so much is the Roomba, the vacuum cleaner. And obviously, it does a fantastic job. But the other reason is she says there's at least one person who always will listen to me. When we talk about robots, at least it seems to me that much of the work, you were talking about delivery of packages from one place to another, that's being done on the surface. What is the state of aerial robots? Is the field, does it have a good handle of that issue? Whenever we talk about drones, we think about it more in the context of military use, and I know that Amazon has explored the possibility of delivering packages using aerial drones. But where are we on that three-dimensional spectrum, not just the two-dimensional surface, but going aerial?
Great question. So first of all, the usual disclaimer, I can't speak to Amazon. I'm not sure what they're doing. I can only speculate as a technologist who has some ideas to what this challenge looks like. First of all, robots are not infallible. They will make mistakes. So I think something that comes to mind is that what are the set of things that could go wrong with a robot and how you deploy it? I imagine that being a challenging scenario for aerial vehicles. The second thing is that regulatory concerns for aerial vehicles is a lot more complex than ground vehicles. For ground vehicles, we explicitly think about how they will obey the rules of the road, yield when they're supposed to yield, drive on the right side of the road, and so on. Doing that in airspace is actually a much harder problem. You got to suddenly collaborate with the FAA. So this is an example. If you wanted to do this, it's important to ensure that you're having a conversation with the regulatory body for this. So there exists a large number of technical challenges, including, as I said, if something were to go wrong, how do you ensure that you're going to be safe and nothing bad is going to happen to humans? You're no longer planning in 2D space, you're planning in 3D, so perception and planning on a limited compute budget, which is far from everything else, is also hard. But yeah, it remains to be seen as to how this is going to be solved. I just don't have a full concrete answer for you today, unfortunately.
Regulation, yes, but one could also argue that you open up the possible optimal pathway search process in 3D, so much more possibilities than in 2D. So Josh, what has been your experience in this aerial kind of a range of things?
Yeah, so the regulatory aspect is definitely there. I mean, we've got some ways to go there. And I'll come back to the AI security perspective on this, because there are some interesting papers and some work in this area where they're able to hijack aerial vehicles and sort of take them over and control them. Some really simple examples are just put something in the environment that's able to kind of hack the software, and then you can make it land. And then that pretty much makes it useless. So there are some important security aspects of these aerial vehicles, and it becomes what would be maybe a nascent use. I'm just trying to move a package from one place to the other. Now becomes a potential killer robot flying out of the sky onto the ground. So that does become a really important aspect. You're turning something that was supposed to be doing good for humanity into something that now is a little bit dangerous. And particularly when we come to swarms, I think that becomes even more interesting and difficult to manage.
So, talking about the current workforce and along these same lines, do you envision a future where pilots, their jobs may be at risk? And if so, how can they be, retrained, or how can they be included in this new ecosystem?
It could be the case that they would be replaced. I think we're very far away from that. An example that I like to give in this case is most people don't realize how important their power steering is. If you lose power steering, you will have a very difficult time steering your vehicle. Same with power braking. So I think we can think about, at least in the short term, AI being more of an assistive technology where you're just helping them do a better job. We have automatic mode for these pilots. They're able to use it in a large portion of their flight. They can even do some landing techniques. We have seen some drones land on aircraft carriers, things like that. But I think we're a long ways away from wanting to replace them. I think we still want the decision making to take place from a human. We don't want to remove that piece of it. So if there is a decision that needs to be made, we want a human to do that. So at this point, we're thinking more of an assistive technology from the AI point of view.
Any thoughts from the two of you?
I think the question is, under what circumstance would you trust this fully autonomous system? And I'm not a pilot, so I can't speak to the scenarios which a pilot would encounter, but I can speak to the scenarios which a driver would encounter. And it does occur to me, yes, there exists a number of scenarios which are simple enough, easy enough, innocuous enough that I do believe that autonomy can help, like highway driving. But in the general case, realistically speaking, like if you're, for example, in downtown Austin, where there's a lot of construction, ambiguous signs, and maybe there's a construction worker who's flagging traffic, this is a very hard scenario to fully automate. I would not, with the state of the art, trust a fully autonomous system. So the question then boils down to, is not whether you can replace humans, but in which scenarios would the human trust this autonomous system to be fully capable? And again, competence-aware plays a role over here. But sometimes our autonomous systems, it might not be easy for them to understand, to be able to fully say that this is not where I'm competent in. Competence awareness is not an easy thing. It's very hard. So sometimes it's hard to say that I'm not good at this.
But it also brings up the issue, right? I mean, sometimes humans are not very good at giving up control, you know. So when I'm driving, I feel like I'm in control. And especially what we find is that for people who are on the older side, driving gives them the sense of being young. They have been doing this all the time, and yielding the driving task to a machine or someone else almost gives them the sense of not being the same vibrant, dynamic youngster that they used to be. So it's interesting how this human machine interfacing, yielding tasks, etc. I mean, how many of us might be willing to go up in the air knowing that there is no pilot out there? I think that's an issue too. And all of these things might change over time, including our own mindsets. But the issue of technology reliability, I think, is on the minds of many of us too. So let's see if there are any questions, any thoughts, any comments from the audience. There's one over here.
Panel. So it's working, okay. So quick question for Dr. Biswas. In terms of human-robot partnerships and social interactions, it would seem that humanoid robots could be more successful in, you know, pressing the button, calling the elevator, communicating with humans and things like that. Yet, from what we've seen, you seem to avoid anthropomorphic robots. Are there good reasons for that?
This is a great question. Actually, I will mention that there are members on the team who are whose expertise is on humanoid robots. So Luis Sentis actually works on humanoid robots, and he's very much trying to get that to the workforce today. Something to think about is that the deployments of robots today is kind of like an intersection between what are they capable of doing and what do we want them to do. And while we believe like eventually humanoid robots should be able to do things better, the state of the art is maybe not quite there yet, which is probably just an artifact of where we are today. But I agree with you that human environments are engineered so much in keeping humans in the mind that maybe the optimal robot of the future might have like a morphology similar to a human. But we're not there today. And if we want to deploy them today, we've got to think about their technical limitations. So that's one. Pepper is, I mean, it's great at the kinds of things it's good for. I think it's as I mentioned, it's a question of which robot is the right robot for the task, right? Pepper is a very anthropomorphic and very human-friendly robot. But on the other hand, if you want something to travel 2 kilometers to deliver a package, the actuators on Pepper are not well designed for that. So we really want like wheeled robots for that. So I'm a big advocate of making sure you choose the right tool for the job, and in this case, picking the right robot for the task is important. Yeah.
Yeah, there's one over there.
Thanks for a very interesting panel. I wanted to follow up on what you mentioned of when to automate and when to allow for human intervention. And one of the challenges of allowing for human intervention is the risk of automation bias, that if the robot is doing most of the things, we'll be too distracted to intervene. And automation bias was actually first studied in the context of high-tech cockpits and pilots over-relying on the tool. And so I was curious if you could share a little bit more about how you're thinking about that design that allows humans to stay aware or to know when to pay attention and intervene.
This is a fascinating question. I really like that question. I think this touches on like a couple of really hard questions. So now when you have, in modern cars, you have adaptive driver assistance systems. And one thing that we have in these driver assistance systems is that they're trying to check whether the human is always monitoring the scenario, which is a good first step. But I think like what we're really missing is the autonomous system somehow conveying what they're capable of and what they're not capable of, right? So so I think this goes both ways. So you want to ensure that humans have a very well-calibrated understanding of what the system is capable of doing. In both ways. You don't want the human to over-trust the system, but you also don't want it to under-trust the system. I'll give you an example of like under-trusting the system where anti-brake locking systems, when they were first introduced, right, before they were introduced, the guidance to drivers were when you're trying to bring a car to a halt in an emergency situation, you don't like slam on the brakes and hold it there, you pulse the brakes, right? But more modern systems have anti-brake locking systems which have control systems which already do that. So now the modern guidance is that just slam on the brakes, trust the car to do it for you, right? So how do we have scenarios where we convey to humans, this is the scenario where you should really trust the autonomy, and when do you have scenarios where the human should be aware of what it's doing and be aware of when it should take over? It's a fascinating question, and I think this is a topic for a lot of ongoing research.
This is an interesting case where, I mean, part of the issue is in terms of the human control, but also, I mean, actually, I think aviation actually is a great case where we have seen a really nice balance of human and automated control. And we have at the same time that increasingly pilots relying on autopilot for more than half of flight now, I believe. You have advances in technology of flight simulators. So you get the same exact cockpit coming off the assembly line, but it gets hooked up to hydraulics and photorealistic displays, and it's a simulator. So, but it's the same environment that someone trains in. So I think that aspect of, you know, using technology to train and prepare people for their jobs. So I think in many ways, aviation's a really great example. But this issue of, you know, when that awareness issue and how to, you know, when to know what to do, it's so different in driving versus flight, I think far less because of anything technical and far more because of the regulatory aspect of there's so many fewer authorized, you know, vehicles in the air than there are on the ground. And when they are, they sometimes get shot down recently. So, you know, we often think about like the cartoon, The Jetsons, and like, why don't we have our flying cars yet? There's certainly some, you know, cost and feasibility, safety considerations, but part of it is just, it is that three-dimensional versus two-dimensional, but you have all these different parameters. If you had 5 times as many airplanes in the air, let alone 100 times or 1,000 times as many, if you think about the number of vehicles that are, you know, in terms of motorized vehicles, ground vehicles in the US today versus the number of airplanes in flight at any given point in time, it's orders of magnitude different. So this makes it so that air traffic control can, you know, alert pilots to potential cases where they're getting each other, you know, even though they're going so incredibly fast, the skies are so incredibly, you know, clear that you have that time to react and prepare and, you know, disengage autopilot, et cetera. Whereas, you know, if we had only 1/1000th the number of cars on the road, you could imagine you could probably blissfully be in, you know, in autopilot in your car, and it would work pretty well, and it could give you an alert when there was a car 50 feet away, because that rarely happened. But, you know, that isn't Austin, of course, and that isn't most parts of the world. We deal with a lot more congestion. This is in terms of how our human societies are structured and the choices we make where, you know, aviation is, you know, much more expensive and it's much more regulated as compared to ground transportation.
The only thing I'll add is the importance of user interfaces. Extremely important and very difficult to build. So when you're building teams from the very beginning, making sure that you include, you know, UI/UX designers, that you include end users that are actually going to be interfacing with these systems. This is something that we've been definitely, you know, working on with engineering and product and project teams within government sponsors. So.
Interfacing, you know, as automation increasingly penetrates into our lives, the other big issue in the context of transportation, which is where much of my work is, as we have more and more of fully automated vehicles, one question that has arisen naturally, and this is not just for transportation, but in many other fields, is what will happen to insurance? Who is going to be responsible? How do you folks think the insurance industry will morph, will evolve, will change? You know, this is a very general question, but I just would like to see what your thoughts are.
Well, I guess it starts with good evaluation of autonomous systems. And I guess this is part of why IIHS it has these battery of tests, and more recently, they've started expanding the battery of tests to include the ADAS system. So they've included things like how good is the automatic emergency braking and things like that. So to answer your question of like how will the insurance systems evolve, I don't know how that will go, but I think it all starts with gathering data. We claim these systems are really good. Under what scenarios are they really good? Under what scenarios are they not so good at? And this really detailed, extensive evaluation actually has the impact to drive change. And an example of this is that when IIHS, again, in this context of insurance, started testing for partial collisions or partial head-on collisions, they detected like it was not very well understood with auto manufacturers. And in 5 years or in 10 years, 5 to 10 years, like auto manufacturers completely overhauled how they were addressing this. So I hope that with this additional extensive testing, we will understand a little bit better how these systems perform and will allow us to think a little bit more about how do you adapt and change them such that they become more capable. And I don't know where the insurance questions will go, but I hope at least it will uncover where these systems are good at and when they're not, and how can we improve them. That's just my take.
I'd also say it's not the first time that technology has been implicated in in collisions as part of the reason for deaths potentially. So there was a large automobile manufacturer, I won't name them, but I think about 15 years ago they had a systemic issue with their brake systems, and they had chosen to not reveal this when they had discovered it. And for years, there'd been this flaw. People died, and people went to jail as the drivers of vehicles that had caused manslaughter as a result of killing pedestrians. And so those people should not have died, and those people should not have gone to jail. But the auto manufacturer was not forthcoming about this flaw and didn't take action either to remedy it nor to alert the public or regulators and officials. So in those situations, if any kind of technology, Josh was mentioning earlier, with power steering and power brakes, how reliant we are on that as well, that if these things go out, then in the case of the braking system, the issue was that people would say, oh, you must have hit the accelerator into the brake by accident. And that was what what caused people, again, literally to go to jail for murders that were the result of negligence of the automobile manufacturer. So this is always, anytime you are, this is society, this is cities, and all of society, all of community, that we're all reliant on each other. And we're reliant on the people who build the vehicles. We're reliant on the people who build and maintain the roads, or fail to maintain the roads in many cases, tragically. And these kind of infrastructural failures and failures in terms of the technology can cost lives, can cost livelihood, can have really major life-altering consequences. And we aren't always thinking about that. So again, that doesn't, that's even for technology that we don't currently think of as being AI per se, but it does, kind of magnify all of that tremendously when we're thinking about increasingly giving more power, more control to the technology.
Okay, we'll take that one last question over here.
Okay, yes, so thank you. I was thinking about the ways that different good systems projects are kind of intertwined. And Dr. Fleischmann, you spoke to the deaf welders and thinking about, avoiding or I guess you'd say, paying attention to that algorithm and avoiding the bias that comes in from this sort of homogenic, user. so perhaps one of the others could speak to the ways in which the user interface being as important and as complex as it is, how you're integrating, not just watching out for racial inequities, but also multicultural differences, differently abled, et cetera.
Yeah, one of the ways in which we are thinking about this is that the scenarios in which we want to deploy these robots will be maybe quite different than where we test them in. An example of that is that, let's say we train them to distinguish like cement sidewalk from like grass sidewalk. Maybe the one part of the city doesn't have cement and grass, like it's like gravel. Like how can you come up with arbitrary scenarios where you might not have thought of? And this is where the potential for disparate impact, I really enjoyed Chad's talk, and he like really drilled down, like keeping an eye out for like disparate impact. This is an example of where unconsciously you can have disparate impact if you're not thinking about like the wide varieties of the scenarios in which you can deploy these systems. So we try to think a little bit about this, and we try to come up with algorithms which can scale, not just like be rigid in like the kinds of scenarios that we're deploying. So that's a concrete example of how we're thinking about this.
Go ahead. Yeah, I was just going to say from a user interface perspective, for the types of users that we deal with, if they find the interface confusing, or if they find it, if you have a lot of false alarms, for example, if it's just not usable technology, they just turn it off. And that's very typically what happens for these types of users. And we've seen this time and time again. So they really quickly reach for that off switch. So making sure that the technology is actually going to enhance their role, is actually going to help them, is of utmost importance. And then also how you translate that information to them is really important.
Good point, Josh. We have the lane keeping assistance feature, and I turned it off the first day I got it. It was too much for me. But thank you all for being here, and please join me in thanking all the panelists. This will conclude this panel over here, but we are going to have lunch, so please feel free to be here, interact, social network, and with that, let me hand it over to our Good Systems Chair, Sharon.
Yeah, again, I'll just echo the very same thanks, and I also wanted to thank our staff, Leah Sabatini, Stacy, Allison, everybody who's been helping the last 2 days. Really fantastic job. Thank you. And thanks to all of you as well for joining us and for making these conversations as engaging as they have been. They can continue over lunch. And I also wanted to remind you that Good Systems hosts a lot of programs throughout the year of one sort or another. So please stay in touch. We have a mailing list. It's very easy to find us a website. It's very easy to be enlisted, and you'll hear more about what we're up to. So please enjoy lunch, which is just across the hall. Thanks.